Hello everyone. In today's lecture, we'll do one example problem to solve a system of linear equations by using LU decomposition method. Okay, so let's take up this problem. Solve the following system of linear equations: x1 plus 2x2 plus 4x3 is equal to 3, 3x1 plus 8x2 plus 14x3 is equal to 13, 2x1 plus 6x2 plus 13x3 is equal to 4. Three equations, three unknowns. Okay, so we need to solve this system of linear equations using LU decomposition method. Okay, so the first step to write your coefficient matrix, then solution matrix, then constant matrix. So A is your coefficient matrix, where you will write the coefficients of the variables. So 1 2 4 3 8 14 2 6 13 is your coefficient matrix. X is your solution matrix. So the variables are x1, x2, x3. You need to find x1, x2, x3. B is your constant matrix, 3, 13 and 4. Let's take some y matrix, arbitrary matrix, whose order is equal to x. So y is equal to y1, y2, y3. Okay, so the first step is decompose. In the last lecture we discussed how to solve the given system of linear equations by LU decomposition method. So we discussed LU decomposition method completely. In this method we will just solve the problem. Okay, so first step is decomposing the coefficient matrix into product of lower triangular matrix and upper triangular matrix, and we will apply Doolittle's approach. Okay, so now do the product of these two matrices, do multiplication of these two matrices. So when you do that, you will get this matrix. Okay, so your coefficient matrix is equal to product of lower triangular matrix and upper triangular matrix. Okay, so these two are equal. So compare the corresponding elements and find the unknowns u11, u12, u13, l21, l22, l22, u22, sorry, u1, u22. So when you compare that, u11, directly you can get u11 as 1, u12 as 2, okay, u13 as 4. Now we'll go to the second row and we'll compare the corresponding elements. So L21 u11 as 3, u11 is already 1, so L21 will become 3. Okay, so L21 u12 plus u22 is equal to your 8. Okay, so when you do that, L21 you already got 3 and u12 is 2, so 3 times 2 is 6, u22 is 2. Similarly you will get u23. Okay, and then if you do, you will also get L31, L32 and u33. Okay, so by just comparing, you will get all the unknowns of L and U. Okay, only this step is bit tedious. Okay, but this is very simple. Just doing multiplication of matrices, comparing the corresponding elements to find the unknowns. Okay, so once you got all these unknown values, okay, now next write your L and U. Okay, so diagonal elements of lower triangular matrix are all are 1. This is L21, so L21 is 3. So just write 3. Okay, this is L31, so L31 is here 2, so write 2, and this is L32, so L32 is 1 here, so write that 1. Okay, so like that write your L matrix and U matrix. Okay, so once you got your L and U matrices, then the solution matrix X you will get in just 2 minutes or 3 minutes. Okay, maximum of 3 minutes. Okay, so next step is write Ly is equal to B and find Y by forward substitution. L you know, lower triangular matrix, so this is your L matrix, this is your Y matrix, and this is your constant matrix. This is given in the problem. Okay, so when do forward substitution means find y1 first, next y2, next y3. Okay, so if you do the multiplication of matrices, you'll get 1 times y1 plus 0 times y2 is 0 plus 0 times y3 is 0. So y1 is equal to 3. y1 is 3. Okay, next go to the second row. 3y1 plus y2 is equal to 13. Okay, so y1 is 3, so 3 times y1 9. Okay, so 9 plus y2 is equal to 13, so y2 is your 4. Okay, then 2y1 plus y2 plus y3 is equal to 4. So y1 is 3. So 2 times 3 is 6 plus y2, 6 plus 4 is 10. So y3 is equal to 4 minus 10, you got minus 6. Very fast you will get the y. Okay. Next go to the last step. Okay. Ux is equal to y and find x by backward substitution. Okay. So this is your U matrix. Okay, which is already obtained from the previous first step. Okay. So this is your U matrix. This is the solution matrix. You want to find the values of x1, x2, x3, and this is your y matrix, which was obtained from this step. Y is 3, 4, minus 6. Now do backward substitution, means find first x3, x2, x1. Okay. So when you do that, 0 times x1 is 0 plus 0 times x2 is 0. 3 times x3 is 3, x3 is equal to minus 6. So your x3 is equal to minus 2. Okay. Now next go to the second row. 0 times x1 is 0 plus 2 times x2 is 2x2 plus 2 times x3 is 2x3. x3 is minus 2, so 2x3 is minus 4. Okay, 2x2 is minus 4 is equal to 4, so 2x2 is equal to 8, so x2 is equal to 4. Okay, similarly you can find x1. Okay, so in less than 2 minutes, once you find L and U matrices correctly, less than 2 minutes you can find your the solution matrix X. Okay, so that's why LU decomposition method is a fastest method. And if you note, nowhere we did row transformations, we just did multiplication of matrices, then comparing of the corresponding elements and finding the unknowns, and then we did forward substitution and backward substitution. All the steps are very simple. So even if we got 1000 equations or 1 million equations, LU decomposition method is very comfortable to write the code, and all the present softwares uses LU decomposition method to solve the given system of linear equations. Even in Matlab, very soon I am going to make video lectures on Matlab software. Even in Matlab software I will show you how to solve the given system of linear equations very easily. Thank you.